Hello, everybody. So imagine experiencing a brand new roller coaster, okay? So you are quite excited for it to be your first experience, but still, well, you're anticipating, you don't know exactly in what shape you will end up, or steadfast will be your foot when you are done with it. So this was, in a nutshell, our sentiment when we engaged ourselves on the road to the cloud. So good news is that we tried it. We made it mostly alive, and we are now keen on sharing our experience with you all. So I'm Florent Coquelet. I've been working in Amadeus for a bit more than 20 years. I'm currently the DevOps SRE team area owner for an application event-driven, cloud-native, and which is for now for real on the cloud. So I will begin by giving you a small overview of the company, of our application, and the various reasons we were kicked out of our dear Amadeus data centers. And I will then leave the floor to my dearest colleague, Angelica, that will give you some more advanced details on the gory details of the various challenges we faced in terms of security and architecture. So first things first, Amadeus. Well, you most probably didn't heard a lot from us because we are mainly a B2B company. But Amadeus is a leading technology which is investing in the world travel industry and to power it. So a quick question to our attendants. Did any of you take the plane from Europe to come and attend here? Yeah, quite a lot. So I sure did as well. So most likely, your data was handled by our servers, or at least transited through them. So if you are here today, it's a bit thanks to us. You're welcome. So our mission as a company is to empower the various travel industries main actors like airlines, train companies, hotel chains, and allow them to thrive in the business and to shape the future of travel. But people often focus a lot of the main travel elements, such as the plane tickets, the train tickets, the hotel room booking, but the ecosystem of the travel industry is really much more richer than that. So Amadeus is offering products to ensure, inspire travel, but also ensure that pre-trip and post-trip are going well, to handle disruptions, so things totally theoretical like luggage being lost or a plane being rescheduled due to a country launching special operations on another. So, Dynamic Intelligence Hub. So it's a project that we began in 2017, and it was something really groundbreaking for Amadeus, functionally wise, as we try to break the data silos that was existing into Amadeus, and gathering data from all over Amadeus and the world beyond, ingest it in real time, enrich it via correlations of data domains, serve it to internal and external clients via rich APIs, and be able to act on it through a IFTT-like rule engine. The technical side as well was really groundbreaking for us, as it was pretty much the first time that we delved into an event-driven architecture based on microservices, using Kafka as a service bus and MongoDB as an object data store. And around this, so we built a lot of tools and ecosystem, leveraging most of the CNCF technologies, and really keeping sure that at any time we were still cloud ready and also ready to go. And actually, the project worked so well that it gave birth to a new concept, which is IFD, the Internal Fast Data Platform, which in a nutshell is a platformization of our initial project, and we generalize its architecture, the principles, and the operations over it. So this allowed significant advantages for offering this to the rest of Amadeus by having hosting services of production-ready workloads, to have optimization of cost via reusing some of the components and evolving them. Be able to unlock innovation by having a streamlined onboarding process and faster time to market, and overall fostered partnership all over the company. And that's why, soon enough, we had a lot of new friends joining us on this platform, and one of them being the focus as of today, which is Ari. So Ari, aka Amadeus Revenue Integrity, it's a product suite that helps the airlines to identify and act upon reservations that should be probably canceled because there is something not quite right with them. So for example, it can be that the ticket time limit has gone over, that there are some fictitious names into the reservations, like, well, Mickey Mouse, let's take one example, or having some components in it that would require to make connections at the speed of light. So if you are not called Superman, it's not for you. So overall, in 2019, it processed 3 billion transactions and canceled more than 190 million reservations, which protected in average so the revenue of the user airlines between 2 and 4%. Historically, it's a tool that we bought from another company back in 2003. It came with its own data center. We made it evolve to our own standards, and then we decided to make the big jump and transfer it to our IFD platform in order to migrate it to a much recent architecture and leverage all the possibilities that was coming with it. So now let's take a step back. So Amadeus cloud migration. Well, why do Amadeus want to get to the cloud? Because we've got top of the crop data centers and everything is perfect. So what do we have to gain from that? Yeah, well, obviously, the common denominators of the migration to the cloud, proximity, because we've got clients all over the world, so it's a good occasion to have our workloads running very close to them. Flexibility, since our traffic is very shaped by user interactivity, so elasticity is really an advantage. Resiliency, because while having multi-region setup and so on is something that is much more easy to achieve in the cloud than on physical data centers. And overall, having some more innovation and faster time to market, and a good occasion as well to overhaul our security model to migrate to a fully zero trust security model. But all these advantages do not come easy because we have a big scale. We are managing more than 610 applications spanning over 21K servers. So moving everything to the cloud is not a simple feat. So we will do multiple things. We will have bona fide application migrations. Some of them will be fast-tracked by leveraging. So we'll be fast-tracked to the cloud, and some of them will be decommissioned. But you have to consider that to do all of this, the time frame we have is really short. From the time the initial step will be completed, we have to move everything in a bit under 2 years. And obviously, failure is not an option, because I guess you wouldn't be so thrilled to be stuck at the airport because, well, sorry, we misclicked a button during our migration. So in order to gain confidence and to test the water a bit before moving our most critical application, we selected a panel of applications that will be our spearhead to the cloud. And, well, the loop is closed since, I guess, to everyone's astonishment there, our application was selected as such a pilot. So why were we selected as a pilot? So as I've been hammering it pretty much previously, we were obviously cloud native from the start, and we enforced it during our life cycle for the operation as well. And it was also a good occasion for us to get rid of secondary data centers that we did not want to maintain anymore. So summer 2021, decision to go. Again, a very aggressive timeline with the first production that happened between November and 2021 and February. So shadow mode in November and real traffic handled as a master in February. And our objective, which again hammering it, quite aggressive, is to get our 80 airlines there in the cloud by October. So it's really a challenge for us. So, well, I've been promising that. So what were our gaps and difficulties to do this migration? Again, cloud native application, so no worries, no problem, and so on. What could ever go wrong? So thank you, no, of course, I'm joking. So yeah, well, problems. So our application indeed was quite cloud ready, but we have to consider that we are just a little application and we are in the middle of the whole Amadeus ecosystem, which is pretty huge. And we are using and we are having dependencies, especially middleware, that is used across all of Amadeus. And to get these middlewares to the cloud, well, there is work to do. So extra security to be designed. It also as well changes quite a lot sometimes the operational model. And so in the course to go to the cloud, we ran into some priorities and bandwidth issues with the people that were maintaining our middleware. So yeah, so we ended up with pretty much a cloud-ready application, but without, for example, a DB to run, so which is not so nice. And that's when Atlas came to the rescue. So, well, first advantage, of course, Atlas is production ready and cloud native by nature. So, yeah, problem resolved from our point of view. And one additional point, which was really a strong point for us, is the transparent scalability of Atlas, which was really an asset in the way we were designing our migration step by step, so by allowing to grow with the migration. So, of course, production ready, but we are still to test the water a bit. So we did a lot of performance testing with it. We injected randomized production traffic. We had consultancy with the MongoDB engineers to review the correct scaling of the cluster, ensuring that our performances were correct enough. So at the end of it all, we got a nice migration plan with a month-by-month growth of the cluster. And we as well discovered a major application bottleneck that was eating something like 10 more times the CPUs that were supposed to use. So for the gory details, it was an implicit server-side conversion done in JavaScript in the MongoDB server triggered by our queries. A very bad one. So we were good with Atlas. It was fit for your usage, but we still had some homework to do in our application. So first, we had some tooling that was not on our DevOps side, which was not fully using the SSL. So it was acceptable in our data center, but it's truly not in the cloud. And anyway, it's enforced by Atlas. We had as well to modify a few things to ensure that we were using the DNS serve connection scheme everywhere in order to be able to easily conceal the topology of the Atlas clusters. We had some run-ins as well with the database user management, where we were defining them and how we were defining them. And so the optimizations, killing the problematic queries that I talked about before, and as well doing some cleanup in our data to ensure a smooth migration. So I guess I'm done. I will now leave the floor to Angelica.
Thank you, Florent.
You're welcome.
So my name is Angelica Groß, and on the stage here you see two people which are getting close to getting an inventory label from Amadeus, because Florent said he's 20 years with Amadeus and I'm 24 years with Amadeus. But I have to say, you know, what Florent on IFD is doing, you know, it's really the cool stuff, you know, cloud ready and everything. And for my part, you know, we have currently a very challenging time ahead of us with migrating to the cloud. So I'm leading the MongoDB DevOps team at Amadeus, and we are responsible for the industrialization and operation of our MongoDB environments. So what does that mean? So we have 3 ops manager deployments at Amadeus. We support 110 clusters running MongoDB version 4.2. And the clusters are spread amongst 550 nodes, and overall we have 170 terabytes of data. Just for reference, I put here our biggest cluster and our busiest cluster, so that you get an idea, what's the challenges we have as well. Now, when Florent and DAH approached us that they want to migrate to the cloud, Amadeus just signed the strategic partnership with Microsoft. And, we were just looking into the cloud business. So in order to get, to fulfill the timeline constraints, we had to choose Atlas, to make it, basically. So in the next couple of minutes, I will talk about the challenges we faced. You don't have to forget, Atlas was new to us, the cloud business was new to us. So, we have to talk about security in the cloud. And, we store your passenger data. As Florent said, when you fly with us, we store your data. So, we need to make sure that your data is secure. And we go through several audits per year. We talk about the connectivity. When connectivity in the data center was never a big topic for us, But when we moved to the cloud, we moved to an all-closed approach. So every type of connectivity which we need to request. And the big question was as well, how do we connect to an external provider to our landscape? I will spend a couple of words on the automation and how we did integrate the monitoring and alerting in our ecosystem. And last but not least, I would like to share with you a couple of operational experiences. So concerning the security, since the Atlas database is hosted in subscription not owned by Amadeus, we were asked to provide our own encryption management. So Atlas provides file-level encryption and we use our key management system. And we got asked, for example, to rotate the encryption key identifier on a regular basis, as well as to rotate the key vault credentials. Then encryption in transit, that was an easy tick because Atlas by nature enforces TLS 1.2. Then user authentication for the personal accounts, we were asked to provide two-factor authentication and to connect them to our Active Directory. For the application user password, we need to provide a rotation of the key as well, of the password as well, sorry. Then as well, what we have to do is we need to log the authentication and authorization requests. You see a snippet of our audit filter on the slide. That was as well easy because we could take it one-to-one from our on-prem deployments, and we retrieve it via the API calls and we send it to Splunk for further analysis. Then as well on the connectivity, we had several security discussions, and as I said before, it was difficult for us to understand all the implications. And the more we talked with the people, outgoing traffic from our subscription was okay. Incoming traffic was not considered to be liked, if I'm allowed to say.
I can concur.
So on this slide, you see basically our setup, which we have. Unfortunately, I don't have enough time to go through it in detail. But the questions we had to ask ourselves was, how do we connect to the database? How do we connect to the API, to do all the automation? How do we connect to the key vault where we store the key identifier? And how do we connect to Active Directory, that we can connect as well. So for the database connectivity, we chose the private link. There were 3 options for the connectivity. It was either via internet, private link, or VNet peering. And with the discussions from the security office, it was decided we go with the private link because the private link is only allowing outgoing connections and not incoming connections. Yeah. So all the application and our helper VMs and everything, connect via our private endpoint in our subscription, and then via the private endpoint to the database. Concerning the private link, I should add as well, it uses the Azure backbone in our case. So, it's good in terms of latency. For connectivity to the API is hosted on the Atlas control plane, and the Atlas control plane is on AWS. So in order to do so, the only choice we had is to connect via the internet, but we use a very limited IP access list in order to make sure that only traffic from our subscriptions can access the API. Then for the Key Vault, we use the all network options. That was the only possibility which we found working, and we are looking forward for MongoDB to provide us private endpoint support on Azure for the Key Vaults. And then for Active Directory, for the users accessing the control plane, we will have just internet connectivity. For the users accessing the database, we are just in the discussion if we need to use VNet peering or we can resolve it with DNS resolution. Okay. Then concerning the automation, for the automation we use Ansible and Terraform. Terraform for the infrastructure and Ansible for the configuration. So we use the MongoDB Atlas Terraform provider to create the Atlas cluster, to create the private link, and to configure the backup. And the Azure Terraform provider we use to create the private endpoint. We manage the storage account where we store the Terraform state files in, and we manage the Key Vault. For the alerting part, we used our existing infrastructure, so we use Prometheus and Grafana. So initially we started to adapt our Prometheus exporters, which we used on-prem. But MongoDB released some couple of months ago, I think, the MongoDB Atlas Prometheus exporter. And we will look into using this one because we hit limitations when we use sharded clusters. So, but here we still need to clarify the connectivity. And then we integrated this information which we get into our alerting system. In addition, what we did is we configured alerts via Atlas. So we used the API to configure the alerts, and they are sent via email. And we use as well the API to retrieve the alerts and put it into our alerting system. Then I would like to share with you some operational topics. At Amadeus, when we introduce a new module, new application to production, we do a test production cycle. So in this case, what we did is, we tested, for example, the backup and restore. We tested, a shutdown of the cluster and see how the application behaved. Apparently good.
Yeah, no problem.
We did as well, what did we as well? We did the Key Vault rotation, we tested, yes. And we tested the...
Testing the growth of the cluster, that it was as well transparent for us, not causing any issues.
Yeah, so overall, it behaved as expected,
Yes.
Then as well, what we have to do is we provide 24/7 support. What I mean by that is basically, we have to provide, train the people, make them aware of this new component. We had to provide the documentation, and as well, we have to train the team who's doing the on-call support. So we had to go through all the phases that our operational organization is giving the okay for it for production. Then there is another step which I call is get the application to perform. Yeah. So in this step, it's basically all the building blocks are put together, but not necessarily the application is working good at that point in time. So when we started, we hit a bottleneck in the CPU. And what we did is we did several scale-ups from an M30 to an M80 cluster. And then Florent, you invented as well the code changes, which was identified by MongoDB for the $var clause.
Indeed.
And it showed some significant improvement. So, I mean, at the beginning, your update response times were about 250 milliseconds. And now, the questions to the audience, how much did you think it was after the code change? No, not quite. Not quite. It went down to 50 milliseconds. So the update response times were reduced by a factor of 5. So I just wanted to say, the application code changes make differences as well.
Yeah, sometimes.
Sometimes. So, but then unfortunately, you have this triangle, either, your application behaves or you hit another bottleneck. And in our case, we hit the bottleneck in terms of IOPS. Yeah. So what we did is we did even scale up the storage to 4 terabytes to provide 16,000 IOPS. But we still hit the limit of the 16,000 IOPS when we write the checkpoints. Yeah. So our next step is that we move the cluster, which is currently only a replica set, to a sharded cluster. But when we tested it, we've seen that it causes a downtime to the application. Because for a short period of time, I think a couple of minutes, 2-3 minutes, the application is not able to connect. So the lesson learned here, when you need a sharded cluster, you configure a sharded cluster from the beginning, even though it has just one shard. And then we have a wish list as well for MongoDB.
Please take notes.
Sorry?
Please take notes.
Yeah. So, when Microsoft provides the LSV3 VMs on Azure, we are really looking forward that they are implemented then as well in Atlas. We are looking forward for the Splunk integration for log files. We are looking forward for the private endpoint support for the Azure Key Vault. For the connectivity, which I mentioned before, for the Prometheus exporter, we would like to see them being available via the private link. And for the audit logging would be to provide the source IP addresses, which are currently masked by the private endpoint. Okay. So the key takeaways, we made it.
Yes.
I want to say thank you to the team, and especially as well to MongoDB Professional Services and to our named technical support engineer. And what's next? We're going to have joint studies with MongoDB for moving our databases to the cloud. It could be MongoDB Atlas. It could be MongoDB managed by Amadeus. Thank you.
Thank you. So I don't know if there is any time left for questions, sadly, or not. Okay, so feel free to fire. Yes?
I saw your data profile showed you had 170 terabytes in your data center. Is that what that was?
Yes.
How much have you actually moved to the cloud?
That's a good question.
380 gigabytes.
It's just a start.
You're just beginning.
Yes, we're just beginning, and that was, if I'm allowed to say, it was our big challenge as well. We were just beginning.
It took a while, right? What are you using to move your data there in a timely manner?
For DIH, it wasn't a problem because they started from scratch. Yeah. But, you've seen yesterday's presentation about C2C, cluster-to-cluster replication. So that would be our main tool to use to move the data from on-prem to the cloud. I mean, MongoDB provides as well other means of moving the data, and we discussed internally as well, for example, to add an additional replica set to move the data. But our main focus would be to use C2C, cluster-to-cluster replication.
If you have that luxury, if you're not on a different data platform to get there in the first place.
No, it works.
From SQL Server to?
Oh, from SQL. Oh,
yeah.
no.
It's another
no.
problem.
That's another problem.
Yeah,
That's another
we are
problem.
mainly looking at here MongoDB to MongoDB.
Yes.
And for other providers, we will see anyway. But so yeah, Amadeus in general is using a lot of technologies.
And what was your transactions per second you were doing in the cloud?
So currently we have something like 16 platforms, and in average each of them are doing between 100 and 200 TPS. So two multiplication.
You see here a quick overview of how many, but I'm not able to read it.
It really depends on the activity anyway. Since when people are doing bookings and so on, or searching, we've got surge of traffic. So it's not something very regular. Yes?
So how you are achieving high availability on the Mongoose? Are you multi-region, multi-cloud?
We are in one region, but we use different availability zones.
Oh, within the same region?
Exactly.
But there could be a possibility of entirely.
Yes.
Totally.
Yeah, definitely.
By nature, so the application that we moved to the cloud for now is not of the most stringent SLA that we have. Okay, we can afford to be down for a few minutes. We can catch up afterwards, especially with the streaming architecture and so on. So yeah, for now, it was not really a concern of having this resiliency to the max. But that's something that we will be working on soon, because yes, there are some more applications that themselves are really more asking in terms of SLA.
And another question on the backup and restore.
Yes.
So while doing the restore, right, like your application clusters can be down.
What we did for the, when you have to restore it to the original cluster, yes. But for the restore testing, we spin up an additional cluster in the same project, which has then the same access permissions, and we just restore the cluster. So this is transparent to the application. And they use the snapshot feature on Azure for the restore. So restore takes about 15 to 20 minutes. And it's not dependent on the size of the database. Okay. The connectivity slide? Oh, sorry.
So sorry, I did not hear you correctly.
Sorry, I'm going to be a little bit louder. From a business case perspective, were you able to identify cost savings, and would you be able to say where specifically those cost savings were?
Well, yeah, as I said, so our traffic is heavily depending on the user input. So it goes really from minimal transaction to really to the peak ones. And in our own data centers, well, you are always providing for max capacity. Okay, and so yeah, the cost savings that we are identifying there is to be really more agile on providing computing power to be able to scale up and down according to the traffic. So it's
Kind of expanding your data center.
yes, and yeah. Sorry, I'm not hearing you properly. For this application, so the one that we began in 2017, we were using MongoDB from the start. Yeah, we
Any transformation or transfer from other DB to Mongo in any of your applications?
So I'm not sure if I understood correctly, but anyway, we were quite cautious, so we tried to keep things a lot agnostic, let's say. So to be able to eventually swap things and so on and so forth.
The question was, do you have any experience on moving something which is not wasn't on MongoDB, something else to MongoDB?
Personally, not.
No, me neither. Sorry.
But yeah, probably in Amadeus we will be able to find someone that did.
Do you have a specific use case in mind? You can come see me and we can chat about that, by the way. So.
So yeah,
Use zone-based sharding.
yeah. So when we first tried, we were hesitating a bit because yeah, multiple options with advantages and drawbacks, and we were quite helped as well. So by our MongoDB consultants to try to find the correct sharding keys.
Mm.
So we mostly use the variety of range sharding keys when applicable. But for example, we've got some IDs which are monotonically increasing, like ticket numbers, for example. And for this one, obviously, range is not a good choice. So yeah, using hash and so on. Yeah. Okay. Thanks a lot, everyone.
Thank you.